When trying to establish conceptual understanding of fractions, I get out pattern blocks. And to begin with, I just let them kind of play around. They have to get it out of their systems. They start stacking, they make towers, they make rocket ships, they make flowers. But some kind of begin to, start piecing them together to notice that 3 of these make this. And so I let them play around for a few minutes before I ask them to clear their workspace. Once they begin to clear their workspace, I will ask them to get out specific pieces. So we just play around with just parts and wholes for them to determine that, oh, okay, it takes 3 pieces to cover up this one. Then we can begin to dig a little deeper and talk about what that would look like as a fraction. I then move into, again, more specific pieces, and I get a little deeper understanding. Well, what if the parallelogram's the whole? What does a triangle represent? But maybe what if the triangle is the whole? What would the parallelogram represent? We continue with that line of thinking, letting the parallelogram be the whole, and we just begin to build upon our triangles. So what if we have 2 triangles? And they begin to realize that that is a whole. We realize that there are 2 pieces, and it takes 2 to make a whole, so 2 over 2 equals 1. So we start to begin to talk about how they could represent whole numbers. We then move on to 1 piece, 1 triangle, 6 triangles. As we get to 6 triangles, they begin to start establishing the understanding that 6 halves equals 3 wholes, because they start counting by 2. So 2, 4, 6. They start recognizing that we could write 6 over 2, and when we do that, it's an improper fraction that could be converted into a whole number. We move on to 12. At that point, once we get to 9, and being an odd number, some of them start to begin to get a little confused, or that concept has become really grounded. That odd piece, they aren't sure what to deal with at first if their conceptual understanding is still a little weak, but eventually we establish that that is 4.5. Now, again, we will count and say, okay, well, we've got 9 halves this time. What does that improper fraction look like? And how can we convert that into a mixed number? We will continue that with other shapes and allow them to see that in a variety of shapes so that we begin to develop a conceptual understanding with students that just may need a little more time working with the concept of fractions.